Good evening. Hello, everyone. Welcome to Big Bang Data Science Solutions free sessions on any topics related to data science and artificial intelligence. We welcome everybody to participate in this program. We had many sessions in the past. So if you have anything that you are capable of doing or you want to share, we are going to give you an opportunity. So to take that fear out of the test,
Hello,
business class.
Yeah.
start speaking loud. Please mute yourself. So yes, next week, Sister Dana, she has approached me with a crash course in statistics. So if you still have any doubt, any concerns about the statistics, we are going to have an expert in the field who can definitely do a demo or do a 1 hour, 1 hour, 2 hours crash course in statistics. And of course, we are going to be so happy. We'll be so happy if anyone in this room can teach anything. Python, R, statistics, machine learning. You're really, that is one way, trust me, guys, this is one way of building that confidence in yourself. Okay, today we have a special guest, Sister Nadia. She is a data scientist. I am not gonna talk about her. So I'm gonna let her talk about herself, explore some of her skills, capabilities, and of course, she will be sharing some of her experience in the computer vision and deep learning in general. And as a matter of fact, we are planning to establish a program in computer vision. There are three specialties within data science that I would recommend any one of you guys to find a way to specialize in one of them. You could specialize in NLP, natural language processing, which is a technology or a learning designed around text, text mining, text analysis. And you have seen the chat GPT Hive that went viral across the globe. So yes, NLP is one of the specialty, and that is my specialty. I love it. I've been enjoying it, and of course we are going to have an NLP program. We are going to have an NLP sessions, and also I'm planning to conduct a 15-week free training program in NLP with Python. I did it 2 or 3 times, and I'm willing to do it with you guys, for you guys. And I've been asked, I went to one of the best Moroccan university. It's located in Ifran. It's called Al Akhawain University, and they asked me to teach NLP for their bachelor's, master's, and PhD students. Maybe most likely I'm going to do it in summer. Just I want to share with you how important it is to invest money-wise, time-wise, effort-wise to learn NLP. The second specialty is computer vision, where you got the engage, the videos, the movement detection. I think there is a special word that I don't think about it at this point of time, but it's all about anything that is emotion, that movement, that can be used in a variety of applications at the airport, used around your security cameras. It's a growing field, and this is specialty. And the third is the graphical analytics, which I have no clue what it is, but I know this is another specialty that someone, once you complete the program, of course, you understand the basics, you understand a lot of things. Then if you have time, you could specialize. Okay, so in the name of Big Bang Data Science Solutions and all the students taking this journey with us, we warmly welcome to Sister Nadia Taoufiki for taking the time, putting all this. I know this is a valuable time, her time, doing this voluntarily without asking for any, compensation. Simply wants to volunteer to share her knowledge and experience with us. So I'm gonna turn off my camera, and I'm gonna pass the floor to Sister Nadia. Nadia, please go and share your screen and take it from there.
Hi everyone, thank you so much for the short intro, Dr. Mohammed. So since I have just 30 minutes, I'm gonna jump quick to the presentation and walk you through the computer vision, self-driving cars, and deep learning. So there are three very important elements that go with each other. So let me share my screen and let me know when you are able to see my screen.
Yes, we do.
Perfect.
But not, yeah, here we go. Yes, you're all set.
Confirmative.
All right, perfect. So is everyone able to see my screen, right? So let's proceed. So hi everyone. First, I welcome to self-driving cars, deep learning, and computer vision demo. First, I would like to thank all of you for joining this demo, and I hope you will find this demo useful and informative. So this is the agenda for this evening. We'll be tackling or going through three main questions. What are the self-driving cars and how do we need them? What is the computer vision and why it's important? And then we're gonna dive into the deep learning, and we're gonna just talk a little bit about neural networks. So the first question we need to answer are, what are the self-driving cars and why do we need them? So let's start with the first question. What are self-driving cars? Well, self-driving cars are capable of moving from one point to another without human interactions. These advanced vehicles are capable of sensing the environment and navigating without human interventions. These vehicles are powered by several advanced sensors, such as LiDAR, which is like stand for the light detection and ranging. And we're gonna also talk about all the sensor later on, probably if we get the chance to provide a full course about computer vision. And also we have the video cameras and GPS, which is nothing but a global positional systems. These measures out of the sensors are interpreted by the advanced computer vision and artificial intelligence algorithms to have the vehicle feel its surrounding and make smart decisions. Therefore, self-driving cars can identify appropriate navigations, paths, avoid obstacles, steers, accelerate the brake safely, similar to how human drives. So the next question is, why do we need them? Self-driving cars offer safe, efficient, and cost-effective solutions that will dramatically redefine the future of human mobility. So let's see some of these benefits. First of it is fewer traffic accidents and congestions. 1.4 million dies in traffic accidents every year, in which 90% of those accidents are caused by human error. Either someone is driving while he's texting, looking at his phone, maybe he drank. So all those probably will be like causing accidents and will definitely be considered as human error. Self-driving car can cause less traffic accident compared to human drivers, since they are equipped with advanced sensors and technologies that can outperform humans in every aspect. Self-driving cars are programmed to obey traffic law, such as speed limit, avoid distractions, and therefore eliminate human error and increase productivity. Average US employees waste around 2 years of their lifetime just commuting, and I believe every one of us is, especially the one who go to the office, that they waste a lot of time commuting every morning and every afternoon. So can you imagine that you can sleep, play game, or read a book while you're commuting, and instead, self-driving car will make your commute time way more productive and enjoyable. Enhance mobility. Self-driving car will improve mobility for the disabled and older people, since they don't have anyone to drive them. Well, you might not need a parking close to your place anymore, especially for congested cities like Manhattan. Self-driving cars could park in its own far away and be called later as needed. Improve fuel efficiency. Everyone knows like the price of the gas is getting very high. So probably with self-driving cars, you don't have really to worry about the gas price anymore, because it can optimize the fuel economy and help reduce harmful emission by optimizing the acceleration and velocity profile. Now let's move into the next slide. As Mark Zuckerberg says, if we recognize that self-driving cars are going to prevent car accidents, artificial intelligence will be responsible for reducing one of the leading causes of death in the world, which is accidents. I have a video here that shows how Tesla car, which is like a self-driving cars, what the car sees and how it drives itself, but I cannot exit now from the PowerPoint. Maybe we can come back later on for this one. So the second questions we want to tackle: what is computer vision and why it's important? So the computer vision is a field of artificial intelligence, and that enable computer and systems to drive meaningful information from digital images, videos, and other visual input, and take actions or make recommendation based on the information. In very simple words, computer vision is nothing but a science that allows computer to understand images, videos, and determine whether computer see or recognize. Let's take an example in here to see, like, make a comparison between human vision and computer vision. So human vision requires coordination of the eye and the brain to functions, while the computer vision uses machine learning technique and algorithm to identify, distinguish, and classify objects either by size, color, and to discover, interpret patterns as visual data such as photo and video. Let's take the first example, which is the human vision. So the human use their eyes as a sensors. As you can see here, we have an image, but each of us can see either one horse, probably two horses, or maybe you're gonna say it's mountain, or maybe it's a farm. But it depends where you're looking at right now. So, and that's by using your sensors. And then it goes straight, so it sends signals straight to the brain. It does the interpretation, and it sends back the response. And the response will be, okay, this is an image of horse or horses, mountain, farm, or all of them together. Taking an example of the camera in here, which is not an eye, so the human being is not looking at the image the same way that the camera will be. So here we have an image taken by a camera. So the computer here, what we're gonna do is that it's developed, it goes, so the image is processed through a number of pixels that will be performing an algorithm, and then from that algorithm it will be providing the guess. So again, the camera is not accurate as the eye of human being. As I mentioned, that the camera will be working either by detecting, or the algorithm that we'll be using in here either will be using it's basically using different algorithm, and also it use different patterns, whether it's gonna be use the size, or it's gonna be use the image, the color, or maybe the edges, and depends of those patterns, it's gonna be predict, or like say, okay, classify our image, whether it's one horse or more than a set of or group of horses, or maybe mountain, or maybe farm, or maybe all of them. Now, why the computer vision it's important? So for the computer visions, it has a lot of importance because when we are talking about self-driving cars, we cannot there will be no self-driving cars without computer vision. And here we can see also we can see also face recognition like Facebook tagging. Let's say you have post image on your Facebook and it automatically tag based on the image, so it will be recognizing each of the images exists, each of the faces exists within that image, and it will tag using like a name that definitely will be a registered user email within the Facebook. And we have also handwriting recognition is one of the utilization of the computer vision. Here we have the license plate number detection, and also we have the snapshot filters. And without forgetting the healthcare domain, which is like where the computer vision has contributed significantly to the development of health tech, automating the process of looking for malignant moles on person scans or locating indicator on X-ray or MRI scan. It's only one of many applications of computer vision algorithm. Please, if you have any question, you can just feel free to stop me. So for the computer vision algorithm, we have multiple, includes a lot of algorithm that uses different methods to understand the object in digital image and extract high dimension data from the real world to produce numerical or symbolic information. There are many other computer vision algorithms involved in recognizing things in photographs. Some common ones are like object classification, like what is the main category of the object present in this photograph. We have object identification. What is the type of object present in this photograph? We have object detection. What is the object in the photograph? We have also object segmentation. What is the pixels belongs to the object and the image? And we have also object verification, where the image, which is like, is the project in the photograph or not? We have also object recognitions. What are the objects present in this photograph and where they are located? And the last one, we have object landmark detection. What are the key points for the object in this photograph? Many other advanced computer vision algorithms, such as style transfer, colorizations, human pose estimation, action recognitions, and more, can be learned algorithm aside deep learning. Moving to the next slide, we are coming to the most important thing in here, which is like deep learning. So for the deep learning, we have a lot of algorithms. We have artificial neural network, which comes by ANN, and we have CNN, which is convolutional neural network, and we have RNN, recursion neural network. So the CNN it's used for image segmentation. So there is three keys or three things you need to know while you studying deep learning. What is deep learning, how it works, and how it learns. Deep learning is a subfield of machine learning that's inspired by the structure and the function of the brain, and it knows as artificial neural networks. It involves training artificial neural networks on a large amount of data and using these models to make decisions and prediction about the new data. Simply say, or if we want to make a very easy introduction, what is deep learning? Is like teaching a computer to see, hear, or understand things the way we do. Just like how we learn by looking at things, listening to sounds, or reading books, a computer can also learn by looking at pictures, listening to sounds, or reading text. So when we are saying looking, so Dr. Muhammad just mentioned natural language processing, and that's come under reading text. So we can fit a text into our deep learning algorithm, and it will be predicting the next sentence. The computer learns by looking at many examples of things, like pictures of cat or dogs, or sign of people talking. Each time the computer looks at an example, it gets better at recognizing the patterns and features that makes up the things. So it's very similar to human behavior. We see things the first time, the second time, and the third time. This is how we learn. Okay, this is the sound of the music, or this is the sound of something else, or maybe we are learning a new language. We got to learn, like, probably we heard a term for the first time. Next day, definitely we're gonna forget it, but if we heard that word again and again and again, definitely we're gonna say that word, and it will be probably used in our daily talking. So it's very similar the way the computer learns and predict when we fit a new data to it. So once the computer has learned from many examples, it can then look at the new pictures or hear the new sound or make prediction about what it sees or hearing. This is how computer can recognize people faces in photos, translate languages, or even play games like chess or Go. Just like how we get better at things by practicing and learning from our mistakes, deep learning models also get better with more example and feedbacks. It's really cool way that we can teach computers to do things what we were once only possible for humans to do. So let's review some concept. As I mentioned earlier, we have a lot of we have three algorithms that goes into deep learning: ANN, CNN, RNN. So ANN stands for Artificial Neural Network, is a type of machine learning model that is inspired by the structure and functions of the human brain. ANN consists of a large number of interconnected processing nodes called artificial neurons, or perceptrons, which are organized into layers. So this is like a neuron in human brain, and this is neuron and neural network. So let's try to understand why we kind of, this is very similar to the human brain neuron. So we have dendrites, and we have neuron, and we have the axons. So the dendrites, it's where it's the receiver of the signals, and the neural is the one that's process the signals and through the axons, and then it goes to the brain, and then it goes back for the feedback. So you see, probably you are driving, and then someone is a new car is trying to pass you, probably. So you saw the car, and the signal goes through the axons to your brain. Then you want to take an action. Probably you want to slow down, or you want to move to the next line. So this is very similar to what neural network does. So here the X1, X2, Xn is nothing but the multiple factors or features or independent variable that we are feeding into our neuron. Let's say we want to predict the house price of a house. Then we're gonna feed probably the size of the house, the location, and different other features into our neuron, and it goes, and each neuron is connected through this is our axons, but those are nothing but connectors, and every connector assign a weight. It depends on the importance of each of those input. So probably for the house price, the most important features is the size. So if the size is big, the weight of the size will be higher than other features. So it goes through the neuron, and then it will predict the price. And it keeps learning by feeding different observations. And every time we run this process, it goes, basically we are running multiple epochs, or we do an iteration, and it keeps learning. So every time we will be updating the weight, because simply saying, so it's like a puzzle that tries to figure out what things are. So the puzzle has a lot of tiny pieces called neuron. Okay, and they all work together to figure out the answer. Just like how we use our eyes, brain to recognize things like dog and cats. A neural network uses this neuron to recognize things in pictures, sounds, or even numbers. Each neuron in the network gets a little piece of information, and that's through the weight. So that will give a piece of information, X2 will be providing a piece of information, and XM will be providing a piece of information. Like, for example, for pictures, the information is nothing but pixels. And then it decides whether it's important or not. Then it passes on its decision to the next neuron, and then which makes its own decision, and so on. So this basically this neuron is just a simple neuron, but in the artificial neural network, on any other algorithm like CNN or INN, we're gonna be having a lot of hidden layers. So the first one, so let me show you here, it will be more clear. So we have input layer, and we have hidden layers, and we have output layers. So the hidden layers, we're gonna have multiple hidden layers, and we keep transforming our weights or our information into the next hidden layer until we hit the output layer, and which will be the decision. So it's a kind of like a team of detectives working together to solve a mystery. Each detective has a different clue, but then they put all the clues together. They can figure out who did it, and the same way the neuron and neural network work together to solve a problem. So the neural network are used in a lot of different things, like recognition faces, translating language, or even playing games. They're all good at finding patterns and figuring out things like that are hard to human to do on their own. So let's say you went to a restaurant, you tried a soup, and then you came home and you tried to do the same soup. So the first you need is ingredients. So the ingredient is nothing but input layer. I'm sorry, I'm using those terms because I'm trying to simplify things to make it more easier for you, or to make you more excited to go and learn more about deep learning. So going back to our example, Dr. Mohammed, please stop me if I'm taking out of a lot of time.
No, please proceed. You have the time is yours. Just proceed.
Okay, thank you.
No.
So as I mentioned, going back to our, I don't want to make people hungry, but let's take an example of a soup. You went to a restaurant, you tried a soup and you like it, and you came home and you want to do the same soup. So the ingredients within your soup is nothing but the input layer. And then you're gonna try to cook the soup. And then every time the process of cooking is nothing but the hidden layer, because you keep adding and adding with different weights. Different weights means like the amount of water will not be the amount of spices. And then the output layer is nothing but your soup. But you realize, oh, your soup is a little bit saltless, so you want to add more salt. So what it goes, it's backward towards it's, so it go, there is a process that called back propagation, where it go backward and try to fix the weight. Means like if you put a half spoon of salt, probably you want to put a full spoon of salt. So that process is called back propagation, because you want to fix the error, which is nothing but the loss functions. So at the end of the day, you want to minimize your loss functions by adjusting the weights. So this is like a very easy example to explain how the process of artificial neural network works. So here we have an example of the dog and cat. So here we are trying to figure out things like whether this picture is cat or dog. So it's nothing but a puzzle that's made up of a lot of tiny pieces that's called neuron. As I mentioned earlier, each neuron has a job to do, and they all work together to solve this puzzle. When you give a puzzle a picture of cat, the neuron at the first layer look at the pictures and decide whether each tiny piece of the pictures is most important or not. So it will take the pixels of the image, and it will decide whether those features are like, what other features are more dominant, the dog features or the cat features. So then they pass their decision to the next layer of the neuron, which does the same thing. This process continues until the last layer of neuron make a decision about what the picture is showing. If the last layer of the neuron decides that the picture is a cat, then the puzzle has successfully recognized a cat. To help the puzzle get a better recognition things, you can give it a lot of pictures of cats and dogs to practice with. That's why when we are training our model, we have to have enough data to make our computer learn and then make a better prediction on the future. As it's practiced more and more, it gets better at recognizing the difference between cat and dogs. Sometimes the puzzle might make mistakes and think a picture of a dog is a cat, probably because we have very similarity between a picture of a cat and dog. But that's okay. You can show it's the right answer, and it will learn from its mistake and get better for the next time. So an artificial neural network works on a similar way to the puzzle, except instead of pictures, it can recognize patterns. And please, I'm highlighting the patterns word because that's what the machine learning is trying to do. It's recognizing patterns and things like sound, numbers, even spoken words. And it's really good at finding patterns and making decisions based on them. So it's used in a lot of things like recognition faces, translating languages, and even playing games. As you can see here that as we speak, the automotive industry is experiencing a paradigm shift from conventional human driving vehicle into a self-driving car powered. As the world advanced toward the driverless features, the need of experienced engineers and researchers on this emerging new field has been more crucial. I'm super excited to be part of this evolution. Me, myself, I'm still learning, and I hope you will all take part as well after you take this training. Thank you so much for your time and for your attention, and let me know if you have any question.
Thank you, Nadia, for this great presentation. Do you guys have any question, any concern, any doubt, any suggestions? Please feel free to take the mic and speak up.
Hey, Nadia. This is Khadija, and I second Dr. Mo. Thank you so much for the lovely presentation. And I just have a quick question here. If you want to go, please, back to the slide for the objective.
Sure.
Thank you.
Which slide?
No, if you go back.
Okay.
Go back. Back. Oh, it shows different objectives.
Okay. Is it related to computer vision?
That's correct. It's related to computer vision, yeah. And you were talking about different vision, different objective. Maybe go forward.
Maybe this one, where we're trying to
Correct.
Okay. Yeah.
So yeah, so you were talking about two different objective when it comes to computer vision here for
Yeah.
self-driving cars here. Are you using a different algorithm for each objective or only one algorithm for all the objectives?
Okay, so basically this is not for self-driving cars. This is the utilization of the computer vision itself. Means like we feed an image or a video to an algorithm and then predict or let the computer tell us what he sees. So here we are using, so as I mentioned earlier, if you want to predict, if you want to process with imaging, the most useful algorithm is convolutional neural network, which is nothing but CNN.
Mm-hmm.
But if you want to go with translation or natural language processing, then you need to focus more on RNN.
Okay. All right. Thank you.
Yeah, sure.
Yeah, this is Kashif. Thanks for your presentation. I have a question related to this self-driving cars. So is there some preconditions for the road, like where these self-driven cars can drive? So for example, there should be dividers, sidelines, signals, and all those things.
Definitely, yes. Let me show you, by the way, a demo to like provide more insight about how the self-driving car works. Do you guys see my screen?
Yes.
Okay, so the way that it works, it's by providing edges on each of those objects while the car is driving and try to recognize each object, even also the line, to see whether he has to make a left turn, right turn, or keep straight. And here there is a stop, so it has to stop. So it has 3 cameras. We have here like left board vehicle camera, and we have medium range, and they have a right one to keep tracking each object. Was it
So how about when it is driving and, for example, there is a turn, but in front there is some wall, and on that wall there is some picture having some persons or some like way.
Yeah, because when we train the data, we train the data also to make, so this is still not very, very safe to just count on the like on the prediction. That's why we have to feed more data into the model and teach the model to recognize the object and predict it well. And one of them, it's whether this is a cartoon, a real image, or like an object. So that's what the CNN does.
Okay, got it.
Yeah, sure.
So just to add on, so basically how this computer learns, how these computers make decisions is we train them first on millions and millions and millions of objects. Maybe we train them all type of driving outside roads, different weather conditions, and hailing up and down. And so it's not only it's not the computer that's making a decision. It makes decisions on what it learned or it's been trained for many for a long period of time. And of course, if you have a new object, that the system never been trained on, of course, it's not going to make a better decision. That's why Sister Nadia just said.
Yeah, I think, Brother Mo, that's what happened in the first accident, crash of Tesla.
Yeah, it's not safe yet. It's not safe yet to let them drive, but they are coming.
Okay.
I got a quick question. I'm sure you're collecting data all the time, and are you guys? I'm sure you send it data through 5G to central database. Are you analyzing that data in real time, or you analyze it afterward?
Okay, so let me just clarify one thing. I'm not working on the field of self-driving cars. My domain currently it's a healthcare. So I'm dealing with a lot of X-rays and MRI images. So that's the kind of data I'm working on right now. But the way it works, it depends on each company, how they are dealing with their data, whether it's like stream data or like a batching data. Means like, is it a real-time data or like just the data that's stored in some of the cloud or like relational database data if it's not a huge amount of data.
Okay, all right, thank you.
Yeah, sure.
I have a question.
Yeah, sure.
Yeah, so thank you for your presentation. Just I want to ask about how can this technology like the self-driving using deep learning, how can we apply it in when we have the sign like the stop sign is not clear, how we can deal with some road that's I think these technologies apply a lot in America or in some country that we have the infrastructure very good, but how we can deal with it in some country that there is no good road, there is no sign, and there is a lot of people they just cross the road with they don't respect etc. You know what I mean?
Yeah.
Yeah.
Sorry, Nadia, to interrupt you. So the answer is don't use the car in those areas.
And also, just I want to add how we can deal with like when the animal, it's some animals just cross the road, etc. I mean the real animal, not metaphor animals.
Yeah, because it's trained on a lot of, as I mentioned, on a lot of data, and also as Dr. Mohammed mentioned, they feed millions of data, including like animals, because here we have a lot of deers, a lot of other like squirrel, skunk. I mean, a lot of animals that you can hit while you're driving yourself and during the nighttime. But as I mentioned, if there is no signals, please use your hand. Because I mean,
so I have observation, right? So we know that we cannot capture all the data points and everything, right? All the use cases, right? But still, there are some very common use cases, like there's a very big trailer whose body is higher than the body of a normal car. So the sensors of Tesla could not sense the trailer, which is cutting it the car, right? So that's what caused the car crash. So who is responsible? Like how do we capture the most basic what you call all the use cases, all the conditions?
Okay, so there is a lot of features that should be included in our study, including the distance between the car and the object next to the car.
Yes, but this is a trailer, right? The body of the trailer is way above the height of the car, the driving car. So the sensor could not detect the car, the trailer. So that's what happened, right?
Yeah, I mean, definitely they are working to improve these things, but for now, what is the important thing to keep in mind? It's not necessarily if you learn computer vision or like deep learning that you will be implemented on self-driving cars itself. There is a lot of domains that use this algorithm in their daily activities, as I mentioned on the healthcare itself.
Brother, your answer, you get a good insurance.
I think so.
No. So my question is, do we have to wait for a catastrophe to honor this use case? That is the thing, right? We should have, as human beings, we should have designed it in the very first place. We should have covered this scenario. We know that there are big trailers whose height is, if you are in Texas, you can see these big trailers. Like 2 or 3 times the height of a normal car. And
Hey, Iqbal, I mean, if you look at it, anytime they're gonna find a solution, it's when something bad happens. And anything, if you look at the scenario about the COVID, they were talking about the pandemic for like 5 years before that. But once everybody got like sick, everybody died, then they find out, the vaccine, even though they were working on it for how many years. It's always like that. When bad thing happen, then they're gonna find the solution.
Yes. So that's my concern also. We are like too technology oriented. Like we miss the actual business use case of anything. So that's what.
Yes, sorry about interrupting. I think we are running out of time. Thank you, Nadia, for this great presentation.
Yeah, sure. Thanks for having me.
Questions, and of course, we are going to have you again and again. And anybody in the room, if you have the ability to teach anything, please feel free to share it with us. We will host you, of course. And please send a word of thank you to Nadia through WhatsApp, just to encourage her. Inshallah, we're planning to do a deep learning program with her. Is going to be maybe a couple of months from now, but it is going to be an add-on to the curriculum that we already have here at Big Bang Data Science Solution. Okay, thank you.
Can I ask one question more?
Yeah, go ahead, Nawfal.
Yeah. So, what are all the different libraries utilized in the deep learning for the computer vision?
So for the deep learning, they are using TensorFlow and PyTorch. Those are the most important libraries that you will need to learn if you want to work on deep learning.
And for computer vision, there is one great
OpenCV.
Yeah, OpenCV. Yeah, OpenCV means Open Computer Vision. Okay, folks.
Thank you.
I will be Nadia. Would you mind if I share the recording with the team?
Yeah, sure. Thank you, everyone.
Bye, everybody. Talk to you soon.
Can we also have presentation?
Yeah, I mean, it's up to her. Nadia.
Yeah, sure. Yeah, I can share.
Sure. Okay, everybody. Talk to you tomorrow. So tomorrow we have a new session, Learning Git and GitHub. So please make every effort to join us. The reason why I decided to add this topic is I'm struggling with the project I'm working on with New Jersey Transit. Is every day, every time I have to recode, and when I recode, of course, I'm going to lose, or I lose whatever already coded. And trust me, guys, yesterday I worked on a project from 12 a.m. all the way to 9 a.m. It's almost the whole night working on this project because of this versioning problem that I've been struggling with. So please join us tomorrow. We are going to learn from another expert, Brother Adil. He's a Moroccan and he's repeating students. He volunteered to share with us his experience in the Git and GitHub. Until then, you guys have a great evening. Bye, everybody. Assalamu alaikum wa rahmatullah.
Assalamu
alaikum.